Hi there. Well, that's strange. It's always strange when suddenly the video cuts out in these videos, so I'm sorry. But I wanted to consider bearings. We can do these bearing problems like how about south 30 degrees west for 8 miles, and then we're going to go north 60 degrees west for 15 miles. And we draw this. Okay, so I'm starting by going off south 30. I head south 30 degrees west, and I go for 8 miles. And then for the second leg of the journey, I'm going north 60 west. North 60 west for 15 miles. That's 60. Now, this was 30. These lines are parallel, so this is 30. So there's my 90-degree angle that I expect. And of course, if I'm looking to, get back home, I'd like to know the distance. That's generally the easier question they're going to ask. And look, 8, 15, 17 is our Pythagorean triple, or you can plug these into the Pythagorean theorem and solve for this missing side. But the challenge seems to be more in what's the bearing to get home. And the bearing to get home is this blue dotted line. So it's going to be south, something east, or east a tiny bit south. I don't know what that's going to be yet. However, there are some things I do know. I do know that this angle here and this angle here, because parallel lines cut by a transversal, I know that that's 60 degrees. I know that my bearing angle for south something east is going to be 60 plus theta. So I've got to find that theta. Well, conveniently, that theta is part of this right triangle with 8, 15, and theta. So if I do inverse tan of 8 over 15, I get that theta is 28.072 degrees. So if this is 28.027 degrees, and this is 60, that means this whole angle, the bearing angle, will be 88.027. And since this whole thing is 90, it's a little bit up here. So I'm going to head south 88.072 degrees. Second answer plus 60 and 90 minus that answer. Or I could say east 1.928 degrees south. Most people will do this. Okay? Now, I want to say that really wasn't so horrible, but for many people it is. And one of the reasons this bearing problems often feel horrible for people is not because they don't know what that looks like or can't draw an angle like that. It's because they don't make the connections here with their picture. And sometimes that comes by drawing a tiny picture. Make a big picture. Really big picture. I think this picture is too small. I can barely see that wedge there, right? And because I'm making this picture small, it's hard for me to identify what goes where and what is what in this picture. I do strongly recommend drawing a compass rose at each leg of that trip. Yeah, I definitely do that. So there is, though, one thing that I notice here, in the last two problems, this part of my bearing angle was found by using alternate interior angles, and the other part was found by using the right triangle and an inverse trig function. Those together formed my bearing home angle. Okay. There is something, though, that you should watch out for when drawing these. I mean, I certainly wouldn't expect you to use a protractor to measure the angles. I certainly would never expect to see a compass involved in any of this. I mean, definitely do not be using your protractor here. However, you do have to keep these angles and these lengths in mind when you draw the picture. So, for example, this one, south 80 degrees east for 15 miles, and then south 10 degrees west for 30 miles. Now, one student draws this picture this way. So we're starting up here. We're going south 80 east. South 80 degrees to the east. Okay. For 15 miles. And then we draw our next compass rose. And now we're heading south 10 degrees west. Yeah. 30. This is 10 degrees. This one was 80 degrees. So that's 10 and 80. And I got my right angle. Okay. And so the bearing home should be north something west. Unless you draw the picture this way. What if you drew this picture? Okay, you went 80 for 15. You got here, and you went here, 30. This one was 10. Yeah. Okay, so we draw that picture, and now the bearing home. Just go north. So this will be north something west. This will be go straight north. But wait, there's a third picture. We start off, we go 80 east. 80 degrees, 15. And here we draw our next one. And this is much longer. And now to get back home, my compass rose has me going north, something east. So, yeah, first, this almost never happens. So I think your first intuition when you see something like this is you've made a mistake. I think in all my years of teaching, yeah, I've never, I think I see there's, I think one homework problem in this section, or maybe it's in the non-right triangle section where we go straight north. Yeah, but that's like never going to happen to you. So, or more than once, not going to happen. So how do I know if I have one of these or not? Well, I think that's pretty easy for us to figure out. So, for example, this problem, this is the one we just saw, where we would have our alternate interior. This is the one we saw, where we would have our alternate interior angles being congruent, and our bearing angle would need to be this angle. No, our bearing angle would just be this little piece here. So I would find theta, I would subtract 10 from it, and that would give me my bearing angle. Over here, I know that there's theta. No, that's 10. No. What am I missing? South 10, west. Oh yeah, that's 10. Because those are alternate interior angles. But my bearing angle is this one. So if I could find theta and subtract 10, I would get that. So if when you're doing one of these, you get a negative number for your bearing angle, that's when you know you drew the wrong picture. Okay? If if you do your computation to find out that bearing angle, and that calculation turns out to be a negative number, not going to happen. Not going to be possible. Okay? All right. Yeah. Oh, wait. That little wedge there, no, I don't know how big that is going to be this one here. All right. But yeah, we've got to watch out for that. And I'll say the only way that we'll be able to sort of get to feel comfortable with this is if we actually practice these a bunch. I'm pretty sure that you haven't done any bearing problems before. So yeah, take this opportunity to practice these while you have them. Okay, so I want to look at, no, not that one. I'm looking for a problem that deals with Mount Lemmon. There we go. Now it says freedom time. All right, I'll do the freedom time. Yes. Sorry, I'm dithering a little bit. Sometimes I dither. Yeah, let's do Mount Lemmon. Okay, so here's Mount Lemmon, or Baba Duak, if you know the original name given to it. So you're over here on the road, and you're headed towards Mount Lemmon, and the first time you look up from you to the top of the mountain, this is 3.5 degrees. And then you drive 13 miles towards Mount Lemmon. And this time, the angle of elevation to the top of the mountain is 9 degrees. Okay? What I'd like to know is the height of the mountain. Ooh. And so what I want to start by asking you is, how many right triangles do you see? I hope you come up with 2. There's the small one here, and this bigger one here. Okay? So I think these problems where we have 2 triangles, it's so much easier to do them if you draw them separately and label them appropriately. And what I mean by that is, like, I see this as H, and that's going to be H in both of them. And this angle is this angle. And this angle is that angle. Now, this is not 13. This part is 13. Now, I don't know what that part is. So I'm going to call it X. So here I have X plus 13. And this one, well, that's just that X. Okay. Any questions about making and labeling those 2 triangles? Seem pretty reasonable so far? I agree. So what I want you to do is, can you write a trig equation for each of these? What trig function would you use? Would you use cosine? Would you use tangent? Oh, why tangent? Because you have the opposite and adjacent. Okay, so I guess my tangent function here will be tangent of 3.5 equals opposite over adjacent. here I guess I can write tangent 9 equals opposite over adjacent. Fabulous. So we're going to, well, how are we going to solve this? Look, we've got two equations with two unknowns. Luckily, last semester in pre-cal, we reviewed how to solve systems. So one of the methods that we had talked about was substitution. If I multiply both sides by x, I know what h is equal to. So I can take that and plug it in there. Tangent 3.5 equals x tan 9 over x plus 13. Okay, well, since August, I've been saying, hey, why don't you multiply by that denominator on both sides so that you can cancel out that denominator? Now here, even though I say a lot, resist the temptation to distribute, yeah, this isn't a verifying identities problem. This is definitely a time to distribute. So I'm going to have x tan 3.5 plus 13 tan 3.5. Great, that's there. But then the equal sign, and now x tan 9. Okay, so we're just doing a little algebra, just distributing the tan 3.5 to both of those. Okay. Now, in my brain, this is an algebra problem that looks like 3x plus 10 equals x. And so what would you do in this situation? Well, you'd move that x over there so you could get the x's on one side and the not x's on the other side. Well, I want to do the same thing here. So I'm going to subtract this from both sides, which will leave me with 13 tan 3.5 equals x tan 9 minus x tan 3.5. And why did I want to do that? Well, I see two terms, and they have a common x. So I'm going to factor that out. And then, how is all this stuff attached to the x? With multiplication. So if I want x by itself, I have to divide by tan 9 minus tan 3.5. And I know some of you are saying, Mr. Cooper, why don't you just pull out the calculator and figure out what these are? Well, remember how we don't round until we get to the end of the problem? This is less writing than me to have to write the long decimal all the time. So I'm actually not just avoiding picking up my calculator, but instead trying to do less writing. So these will cancel, and I'll have x equals this. You might want to, pull out your calculator and make sure that you can get the same answer I do. Okay, I got that x was equal to 8.178, 349,886 miles. Wow. Oh, but is that our answer? That's right. Is that our answer? No. Why not? Because we're looking for height. Remember, we were looking for height. Okay, so remember here we had this tangent equation. Tangent 9 equals h over x, and therefore x tan 9 was equal to h. Well, I need to take this x value and multiply it by tan 9. So times tan 9. And I end up with 1.295 miles. 1.295 miles. Which I believe is a fairly accurate assessment of the height of Mount Lemmon based on us not living at sea level in our valley. If we did, then this number would be bigger. So that's a type of problem that you're going to have to get comfortable with. It's definitely on the assessment. Yeah, two triangles. So I needed to plug in two variables, right? There was this h and then this x here that I put. So we'll be doing more of these as we move forward, okay? Don't worry. You don't have to be pro master yet of bearing problems or of two triangle problems. But by the time we get to the unit assessment, you will need to know how to do those things. They're not going to go away, all right? Just like linear velocity, just like those scatter plot word problems, yeah, they're not going to go away either. So embrace the learning and ask lots of questions. I'm sure Mr. Paz and I will both be very happy to go and look at questions with you. Okay?